Okay, fine. So in today's session, we will discuss about site and size selection for biogas plant. So the location of a biogas plant should be selected with some parameters. So initially we will discuss about the size of the biomass plant. So it has been decided by following three parameters such as daily feed, retention time, and digester volume. Okay, so daily feed means how much amount of input source we are going to apply on the digester. Okay, so we have discussed earlier. We are having a mixing unit. In that unit, the cow dung is mixed with the water. Okay, so then it will be applied into the digester. Okay. So that daily feed defines the amount of cow dung has been applied on the mixing table. Okay, and next thing is retention time. So yesterday we have discussed how long the slurry has been available in the digester. Okay, so this about 40 days, 40 days to 50 days. Okay, 40 days to 50 days it will be available inside the digester where the anaerobic fermentation is taking place. Okay, then the next thing is digester volume. It means the size of the cylindrical digester. We have seen yesterday there is a huge cylindrical shaped digester is there where the process anaerobic fermentation is taking place. We have discussed. So depending upon the availability of the cow dung, the digester volume will be fixed. Okay, so we will discuss these 3 points elaborately. Okay, so the size of the biogas plant is highly depend on the average daily feedstock. Okay, then the capacity of the plant should be fixed on the availability of the raw material. Raw materials means it's a cow dung or plant waste or any other animal waste. It's not only from cow. There are a lot of animal farms are there. Okay, pig farm, pig farm was there. White pig. So the waste from white pig is also can be used as a raw material for the biogas plant. It has been mixed with the equal quantity of water at the mixing table and it will be applied into the digester. Okay. So capacity of the plant indicates the quantity of the gas produced in a day. So depending upon the size of the digester, it the gas generation will be okay. So if we have a large size of digester, the chamber means it can generate huge amount of biogases. Or else if you have a small size of digester, means it can generate very little amount of biogas. So in that biogas, we have discussed methane is the vital component. Approximately 65 to 70 percentage of that biogas is methane. Okay, CH4. Okay, so based on the study, 1 kilogram of cow dung along with the equal quantity of water Under anaerobic condition, it can produce 40 liters of biogas. So we have discussed equal quantity of cow dung and water is mixed at the mixing table. Okay, so 1 kilogram of cow dung is mixed with 1 liter of water. Okay, so per day 40 liters of biogas we can able to generate. Okay, so there is a calculation is there. We can see, for example, one cow will yield an average of 10 kilogram of cow dung in a day. For one cow, it will give 10 kilogram of cow dung. Okay, we are having three cows. So, how can we find out the capacity of the biogas plant to be constructed? This is the question. So, totally three cows. One cow can give 10 kg of dung. So, totally 30 kilogram of cow dung can be obtained. Okay, and it will be the yield of 0.04 meter cube or 40 liter of biogas. Okay, then 30 kilogram will produce 30 into 40, totally 1200 liters of biogas per day. We have discussed already 1 kg ki we can generate 40 liters. Okay, so 30 kg means 30 into 40, 1200 liters of biogas per year day. So the capacity of the plant should be constructed 1 meter cube. Okay, so minimum of 1 meter cube capacity the biogas plant should be constructed. Okay, so to produce 1 meter cube of gas or 1000 liters of biogas, how much quantity of cow dung is required? It is a reverse calculation. What you have discussed earlier, this is the reverse calculation. So 1 meter cube divided by 0.04 meter cube per kilogram of cow dung. It will be 25 kg of cow dung. Okay, so we have installed a biogas plant with 1 meter cube. Has a size of 1 meter cube means daily we should need 25 kilograms of dung to operate the biogas plant, or else there will be a lagging. Okay, so when a biogas plant is underfed, the gas production will be low. Underfed means it can't be able to supply the cow dung properly. There should be a limit. Here we have seen. So to operate 1 meter cube size of biogas plant, we should have 25 kgs of dung. Okay, suppose we can't able to get this 25 kilogram of dung means the power, sorry, the gas production will be low. Okay, so in this case, the pressure inside the chamber will be not sufficient. Okay, so this is one type of uh, lagging. Okay, another thing is if too much of materials is fed, 1 meter cube sizeல இருக்கிற ஒரு பயோகேஸ் பிளான்ட் can able to withstand up to 25 kilogram of tank. Suppose we are having excess amount of tank, we are having 40 kilograms of tank means definitely it will be overflow. So too much materials is fed means the digester and the volume of the gas is consumed. The slurry may enter the gas pipes and all the appliances. Okay, it will overflow and it will reach the gas tubes also. Okay, so the size of the biogas digester chamber and the amount of tank we are going to fed into the chamber should be calculated as per the given regulation. இங்க ஒரு regulation கொடுத்திருக்காங்க. So we should follow this regulation to find out the amount of cow dung and the size of the digestion chamber. Okay, so this is a formula. It should not be lagging and it should not be leading. That means underfed. அது குறையவும் கூடாது ரொம்ப அதிகமாகவும் இருக்கக்கூடாது. Okay, that's the thing. Okay, there is a table to show you the quantity of the cow dung required for different types of plants. Okay, different types means different size of plants. So if you having 1 meter cube size means daily it should require minimum of 25 kilograms of tank along with 25 liters of water. So we have discussed earlier the same quantity of water is mixed with the tank. Okay, so 2 means 50. 2 meter cube size means 50 kilograms of tank along with the 50 liters of water. So this is a simple calculation. Okay, 1 meter cube means we should have 25 kilograms of cow dung along with 25 liters of water. Okay, then scaling of digester. The size of the digester, that means the volume, is defined by the length of the retention time and the amount of fermentation slurry applied daily. Okay, so it has been found out from this example 25 kilograms of cow dung along with the 25 liters of water. So totally we can get 50 liters of slurry. Okay, so 25 plus 25 we can get 50 liters of fermentation slurry. This slurry has been applied into the digester. So we need to find out the volume of the digester. So our concept is to find out the volume of the digester. So digester volume can be find out by this formula. That means the daily feed in liter per day into retention time in days. Okay, so daily feed we have find out. We already find out it is 50 liters. Okay, so digester volume is equal to 50 liters into we have a retention time of 40 days. Okay, it should be 1 to 2 months for a anaerobic fermentation. This slurry has been placed inside the digester for maximum of 2 months, minimum of 1 month. Okay, so 40 days we have given. So 50 into 40, 2000. Okay, 2000 means 2 meter cube. This is also a reverse calculation. So 2 meter cube means 50. We have initially we have find out 50 liter. 50 liter and the size will be, the volume will be 2 meter cube. In that table also we can find out 50 liter 2 meter cube. In previous session we have discussed 2 meter cube we should need 50 liters. In next session we have find out 50 liters means 2 meter cube. So this is the reverse calculation. Okay. So the main thing is this 40 days and this 4 point, sorry, 0.04 meter cube. Okay. This is the main concept to find out the size and the volume of this digestion chamber. Okay. So next thing is selection of construction site. Okay. Okay, selection of construction site. So it has some important factors to find out the exact place to build a biogas plant. So initially the site the site should facilitate easy construction works. Okay, so we have seen yesterday the biogas plant has been placed underground. Okay, the mixing table is above the ground level, and all the digester and the chamber has been placed underground. So we need to dig a huge tank underground. If there is a lot of rocks, means it is not a easy task to dig. Okay, so for that purpose, the land selection should be optimum. So to build a biogas plant, the land should not have any huge rocks and all. Okay, so it will it will be easier. Only soils are available in the land. Okay, then the site should be such that construction cost is minimized. Okay, suppose that land has lot of rocks means we need to uh, drill that rocks. It will take long time and it will take a huge amount to construct that plant. Sometimes it needs some huge equipment to dig that tanks. Okay, so for that purpose, initially while planning itself, we should aware of that land. What will be underground? Is there any rock? So we should do a case study about that place. Okay, fine. Next thing is the selected site should ensure easy operation and maintenance activities such as feeding of plant, use of main gas valve, and composting and use of slurry, then checking of gas leakages, draining condensed water from the pipelines, etc. So the most important thing is uh, feeding of plant. So we are having some energy crops. Okay, so by yielding that energy crops, we can give it into the mixing table. Uh, Not only animal dung, sorry, cow dung and another animal wastes. We can use plant waste also for this biogas plant. So we have planted these types of crops. That means energy crops. We can use that crops also. Okay. So it should be near by the combustion that digester chamber. Okay, it should not be long far away from that chamber means that should be a transportation cost. Okay, then Usage of gas valve, this is outlet gas valve. Okay, and composting and use of slurry, and gas leakage should not be there, and draining condensed water. So the water should be released properly. It should not be stored inside the or around the digestive chamber. Okay. Then the site should guarantee plant safety. So there should not be any event for natural disasters such as earthquake and all. Okay. So the site selection is done where the site has not any previous history of earthquake and all. Okay, it should free from these natural disasters. Okay, then to make plant easier to operate and avoid wastage of raw materials, especially this cow dung and swine manure means the pig waste. Pig waste is swine manure. Plant must be as close as possible to the cattle shed. Okay, so we should construct this biogas plant as near as to the availability of this cow dung or uh, swine manure or plant waste. Okay, then the site should be in slightly higher elevation than the surrounding. Okay, that's an important thing. This digester chamber should be placed in a slopy area. In a slopy area, because during some floods, the water should not be locked inside the chamber. It should flow away. If we have placed this chamber in a slopy area means definitely during rainy season the water has flowed away from that plant. Suppose we have built this chamber in a lowest area. Lowest area means automatically the water will log inside the chamber. So we should avoid that concept. Okay. So this also ensure free flow of slurry from overflow outlet to the composite pit. So it will help in another way that overflow of slurry. Suppose the slurry is fed exceeded means in a huge amount means it will overflow through the outlet tank. There is a overflow tank. Okay. So if we have placed in a slopey structure means definitely it will come out or else it may reach the gas pipes also. Okay. So it will help in two ways. Okay. Then, for effective function of biodigester, yeah, temperature should be maintained properly. We have discussed earlier, so it should be within the range of 20 to 45, sorry, 35 degrees Celsius, or it may be up to 50 degrees Celsius. Okay, so normal temperature is about 30 to 35. So we need to maintain temperature slightly more than that normal temperature. Okay, so 40 temperature may be the correct thing. Okay, therefore it is better to avoid damp and cool place. So always sunny sides is preferable. So the light and heat from the sun should be strikes on the plant. Okay, wow. And the next thing, to mix dunk and water or flush this swine manure to the digester. Considerable quantity of water is required. Okay, so we have discussed earlier 25 kilogram of cow dung is mixed with 25 liters of water. Okay, for a simple structure. If we have placed, if you like to build a huge biogas plant, there is a huge availability for water. Okay, so water source should be available nearby the biogas plant. So it's purely avoid the transportation charges and all. Okay, so suppose we are having a biogas plant where the water is not available, means we should transfer that water from some other places by means of trucks or lorry, water lorries are there. So it will increases the cost of input source. Okay, so there should be the land should have vast amount of water. So pour போட்டு கூட எடுத்துக்கலாம். Okay, or else we can dig a huge well. From that well we can extract the water. Okay, then that well or groundwater source should be at least 10 meters away from the biodigester. Okay, especially the slurry bit to avoid the groundwater pollution. So we are using groundwater from the well means the pore should be away from the digester because the digester is placed underground. Okay, so we have if we have a well or pore nearby the digester means it may cause water pollution. Okay, these slurries can enter the groundwater and it can mix it with the groundwater. So the groundwater may be polluted, can be polluted. Okay, so at least 10-meter distance should be there between this digester and the pore or well. Okay, if longer gas pipe is used, the cost will be increased as the conveyance system. So it become costly. So longer pipes increases the risk of gas leakages also. Okay, so the usage session will be as near as possible from the production area. Okay, initially we have discussed the input, that means the availability of raw material should be nearby the digester to avoid the transportation losses and time of transportation. Okay, next thing is the consumption area. The biogas consumption area is also should be nearby the digester to avoid the gas leakages while transporting. So we have generated the gas and we have transported that gas through the pipelines. If the length of the pipelines is too long means definitely there will be some gas leakages. So to avoid that, that usage area or the consumption area should be nearby the production area. Okay, that's the thing we have discussed. And the site should be at sufficient distance from the trees to avoid damage of biodigester from roots. Okay, there should not be any huge trees nearby the digester because the digester is made up of bricks and cement. Okay, so the roots of the huge trees can enter the digester because in that digester we are having lot of water. Water content is there. It has been placed underground. Okay, so it has been placed underground. It has lot amount of water. As a property of the root of the tree is to find out the water. So it may enter the digester by breaking the bricks. So we should avoid the presence of trees surround the digester. Around the digester, we should not have any trees. If we are having trees, means the roots of that trees should enter this digester because we are having water content inside the digester. Okay, so it may crack the bricks if the digester walls has been cracked means definitely there will be a cause for gas leakage. So we should avoid. Then the soil should have the bearing capacity. So we have built a plant means we should before construction itself we should test the soils. Soils tensile strength. So there are several testers should be performed during before the construction. Okay, that bearing capacity to find out the bearing capacity. The ultimate concept is to find out the bearing capacity of the soil. Okay, these are some important parameters, important factors. Okay, for selecting the location of a biogas plant. Can see a biogas plant should not be located 5 meters from the field. Okay. The digester sample must be in an open area and should not be near any water sources. If you are having a pool or any river or any lake, definitely this biogas plant should be placed away from that water sources. Okay, or else what will the problem? This slurry, it can be mixed with this water, so that water will be polluted. Okay, so the plant should be situated on a slope, not on a low and not on a low land to avoid the danger of floods. What we have discussed earlier should be placed in a slopey structure. In a low land means definitely the water will be logged inside that digester. Okay, so the excess manure from the expansion chamber should flow into the farmer's field or the storage tank and not into natural water bodies such as rivers to avoid risk of pollution. So we have discussed earlier yesterday class the after generating the biogas, the slurry it has been placed in a concrete tank, huge concrete tank, and finally it has been applied as a fertilizer to the land plant. Okay, agricultural land it can be used as a fertilizer. It should not be mixed with rivers. The waste should not be mixed with the rivers or any other water bodies. Okay, so you can see this is a location of a biogas plant. It is a mixing table and the inlet chamber. This is the compression, that means the digestion chamber is a dome structure. Okay, and this is the outlet chamber. Sorry, this is the inlet chamber. Okay, so here the form is there. It may be cow form or pig form. Okay, the wastages from this form has been given as input along with the same quantity of water inside the digestion chamber. Okay, then the anaerobic fermentation is taking place inside the chamber and it will produce the biogas. This is the gas tube. There is a gas wall, there is a gas tube. The gas can be extracted, and finally, this is the outlet chamber. Okay, the slurry from that outlet chamber can be used as fertilizer to the agricultural land. Okay, input mixed with the water, digestion is taking place, gas can be released, and finally the slurry, that means the disposal, the empty slurry has been applied as a fertilizer to these agricultural lands. Okay, so these are all some important factors to fix the size and site of a biogas plant. Okay, hope you all understand.